Today I would like to discuss the aromatic electrophilic substitution reaction. This is a type of substitution reaction of electrophile with an aromatic compounds. So before beginning the mechanism of aromatic electrophilic substitution reaction, let us see the criteria of an aromatic compound. So the first criteria is the compound should be cyclic in nature, and the second criteria is the compound should be planar in nature, and the third criteria is it contains delocalized electrons which is above and below the plane of the nucleus or ring. The fourth criteria is it obeys Huckel's rule. Huckel's rule is the rule of thumb of aromaticity, which can only determine the final establishment of an aromaticity. So 4n plus 2 pi electrons, that is the minimum number of pi electrons, should be in this particular format, where n is an integer. It is starting from 0, 1, 2, 3 like that. So that means, suppose if you are substituting 0, you should have a pi electrons of 2. If you are substituting 1, you can get 6. That means it should be like 2, 4, 10, 14 like that. Such type of sequence you need for an aromatic compounds in terms of the number of electrons. And finally, the aromatic compounds is always undergoes electrophilic substitution reaction rather than addition reaction. So these are the major 5 criteria of behaving an aromatic character of an organic molecule. It should be cyclic, it should be planar. Planar means nothing but the compound should lies in a same plane. Now we will see about the orbital picture of benzene. So these are the various orbital picture of benzene. So the orbital picture, it is clearly, because I represent the orbital picture by means of 3 various representation. So all these various representation, it is clearly found that the benzene contains excess amount of electrons, that means pi electrons, that can be arranged both above and below the plane of your nucleus. So that means overall, in a 2-dimensional aspect, we are normally representing the structure of benzene is like this. So that means you can see an alternative double bond and alternative single bond. That is the ultimate composition of a benzene nucleus. If you are seeing the structure of benzene nucleus, only 6 carbon atom and 6 hydrogen atom. So that means they are in a ratio of 1:1. And if you are seeing the case of the basic aspects of electrophilic substitution reaction, we will categorize the reaction first of all. So I think the beginning itself I told you that it is a type of substitution reaction of electrophile. So here the electrophile, which I represent by means of a symbol Y+. Electrophile is always electron deficient in nature. So that deficiency, so maybe 2 electrons, that means a pair of electrons. So these electrophiles, once it will attack on the benzene system, so what will happen means one of your hydrogen is replaced by your electrophile, and you will get your finalized product. That means you will get a substituted product with an electrophile. So that is this is a common reaction of all type of aromatic electrophilic substitution reaction. Electrophile can comes as a major role, and it can be replaced one of your hydrogen, and you will get corresponding substituted product. So that is the overall reaction of aromatic electrophilic substitution reaction. So I think we can conclude like this: an electrophile can be substitute for a proton of the aromatic compound. So proton, we know that the hydrogen atom without an electron, so we can commonly name it as proton.